Hello, my name is Jan Ketil Rød and I will in this video talk about basic vector operation. I have three videos and this is the first one about queries and the next one will be about buffer and overlay, also basic vector operations. Most of the content of this video is taken from the Norwegian textbook GIS Tools to Understand the World, chapter 8. Now, what is a query? Simply put, this is a question, a request for information. And in most GIS, one differentiates between attribute queries and spatial queries. An attribute query could, for instance, be that you have a data set of parcels and one of the columns in the table is called zone code. And this may have different values, but you are only interested in those which have the code VAC, short for vacancy. So these are free parcels which may be open for sale, for instance. So if you are a developer, these may be places in town that you could develop. And then the response to this question formulated here, select star from parcels where zone code equals VAC, highlights in the map as these yellow polygons. Now you could also have spatial queries, and then it's often common that you combine two data sets. For instance, you want to know which of these parcels are near to the river, which is then in another data set. And this distance could, for instance, be 250 meters. So that's a spatial query that you want to know where are the parcels that are within 250 meters from the river. And all those which are highlighted green here in the map are those parcels that are fulfilling that query. So this is another example of the difference between attribute queries and spatial query. For instance, if you are interested in selecting Italian restaurant, you could do so by an attribute queries, and you would then be highlighted all those restaurants that are Italian. But if you want to know about all restaurants near your house, for instance, if you want to go out eating, you need to do a spatial query. For instance, selecting all restaurants that are within 3 kilometers from your home. Now you could also combine this is not done here, but you could also combine the queries to know where are all the Italian restaurants that are within a 3 kilometer distance from your home. Now we have three main query building blocks, which we could call the source, the filter, and the relationship between the source and the filter. First of all, we need to know where do results come from, which is the source. And then we need to have a table or a feature class, a shapefile. And in GIS, all feature class and shapefiles, they have an attribute table. And this is typically where the query from an attribute query comes from. So we have a table, but we also want to zoom in on one of the fields, one of the columns in the attribute table. So this we call the source. And then we need to use something to filter out the results. And that could be an attribute value. For instance, shown here, the attribute value apartment, which is in the field type, which we already has identified as a source. And this is then the value which you are searching for in each record of the attribute table. And then you need to establish the relationship between the source and the filter. So this could be like how you do the comparison. So it could be like a logical, arithmetic, or spatial operators. So for instance, here it uses an arithmetic operator called equal to. It filters out then all rows where the attribute value equals apartment and leave that as a result for your query. We use Boolean operators. This is often written by a big letter B because this is named after George Boole, which was a British mathematician who established the Boolean algebra. But within GIS, we use Boolean operators for queries and also for overlay, which will be shown later. Very often, to illustrate the Boolean operators, we use Venn diagrams. This is typically two sets which are then combined. We can have one set A which is combined with a set B. And the Boolean operators are then OR, AND, NOT, and exclusive OR. Most common is OR and AND. So OR is the most inclusive of these operators. So everything which belongs to set A or belongs to set B is included. So the blue shading here is then the response to the request. So this is what will be selected based on this query. If you use the operator AND, this is much more restrictive. Then you have to have the overlapping area. The overlap between set A and set B is then the request for this information. So only which is the part which is common to set A and B. Then the NOT operator exclude everything which is part of the latter one here. So A, not B, means that you will keep A, but exclude everything which is part of the B set. So we then need to exclude this part here. And then the last one, exclusive OR. This actually means that the one or the other, A or B, but not both. So everything which is part of A and part of B is kept, but not the part which they have in common. While the Boolean operator was maybe new to you, I'm sure you are more familiar with the arithmetic operators. So these are typically then less than or equal, not equal to, larger than or equal. I will make some more examples of queries based on the Boolean operators and the arithmetic operator based on this map example shown here. Here I have a small map showing an area which is forest and something else, and we have also contours showing the levels of elevation. So 25 meter above sea level, 30 meter above sea level, etc. So for instance, if we want to know places which are forest or having an altitude higher than 35 meter, this, as you may remember from the Venn diagram, this is very inclusive. It includes everything from the set A, which is here forest, and it also includes everything from set B, which is altitude above 35 meter. So if this is the input map, the shading here are then illustrating the response to this query. So we will get everything which is forest, everything which is green here will be part of the set, and everything which is above 35 meters. So both of these expressions will then be part of the result. If we use the AND operator, this is much more restrictive and only take the common area between the two sets. So you have forest, but you are only then keeping the part of the forest having altitude higher than 35 meters. This leaves us then with this part of the forest here, which is above 35 meter. We exclude the part of the forest which is below 35 meter, and we are not including anything else which is not forest. Then the NOT operator, we have forest, but we should not have altitude higher than 35 meter. So everything which is forest and below than 35 meters is part of the set. So we exclude everything which is above 30 meter because this is after the NOT operator. This should be then excluded. The next XOR, exclusive OR, the one set or the other set, but not the part where they have in common. Then we have the forest and we have the altitude, and please note that here we use less than and not larger than. So here we are looking at altitude lower than 35 meters. And this should be included unless it is overlapping with forest. So whatever is forest and below 35 meter, we need to exclude from the selected set. But then we can also have forest which is then above 35 meters, because that is not part of the set which is below 35 meter. So although in most GIS the queries are becoming easy, it is still useful to know about SQL, which is short from Structured Query Language. So query, we said, is a question. It is a request for information, but still, thus, you may need to structure your question a little bit formally when you are asking the question to a computer system. So then, within GIS, SQL is very common, and this is just one example on how an SQL request would look like. So we have here what we call SQL statement, the selection, and the from and the where are all SQL statements. Then we have a star. This is not very common that you see in GIS, but if you see it, it means that you will be keeping all the fields in the attribute table that you are doing the selection on. So the selection will result in a new set, which you can store in a new feature class, for instance. This little star will then make sure that you keep all the fields in the table. The table, or the source for where we get this information from, is here called cities. So it is a table here of all the cities of the world, and we have two expressions, one related to the capital, which is one field in the cities table, and another one called population, which is another field in the cities table. And then we have arithmetic operators, equal and larger than. So we have an expression saying that we are interested in selecting every capitals. And we have an additional restricting expression, since we are using the AND operator, that the population in this city should also be larger than 10 million people. So these two expressions are then combined using the logical operator AND. And we'll show a demo on this. Now, this is a photograph of a situation after a heavy rain event. Then typically you may see that there is like a little river coming down the road. And it's also here an outlet, which is critical for the drainage system in a city to lead away this surface water. And both of these elements are, for many places, at least in Norway, available as data set. You have the drainage line, and then the outlets is also part of some other data sets, which is here shown as points. Maybe you want to know then, where are those outlets which are intersecting or very near those drainage lines? Having linear features, the outlets as points can be very close to a line, but because a line has no width, if it has a width, it would be a polygon. And because then a line has no width, you can be very close, but the spatial queries does not detect it. So one way of making a select by location is by using a buffer on the drainage line, and then do a select by location using intersect as a parameter, and this is demonstrated in this video. Another option is to use the select within distance, and then set a distance in the tool to select then which are these outlets which are very close to the drainage line. So next demo is about using select within distance.